Hey everyone, good morning, good afternoon, and good evening. My name is Vishwadeep, and I welcome you all on Wallah PW channel. Till yesterday, we have discussed two different types of CPU scheduling algorithms. One was FCFS, and second is SJF, shortest job first. FCFS was having a problem of convo effect, which was saying that if we schedule a process which is very big, in that case the slower process makes the system very slow, just because the other processes definitely will be getting delayed. Hence we tried another algorithm called as SJF. SJF says we will schedule the process which is the smaller first. But in that case, you know what happens? The thing is, in SJF, there was only one issue that we can solve, and that is the preemption. There is no any preemption in SJF. If a process comes first, which is bigger process, slower process, and there is no any other process, then we'll have to schedule that process first. Now the problem is we cannot preempt it. Why? If later on, if a big, very small process comes, then we cannot stop that current big slow process. So that is what the issue which we can solve now with another algorithm called as SRTF. What is the full form? I'll talk about it. But before that, just confirm once if you guys are okay with my audio and video. And till yesterday, whatever I have taught, did you guys check out all the videos or not? Just because once you start learning, don't start from the middle, start from the scratch, and you will understand everything. Gate exam is all about understanding the concepts, just because same questions which we are solving here, that will not come in the exam. So once you understand the concept, you understand the reality behind the concept, and that will help you solving the questions correctly in the gate exam. Confirm me once in the comment box you guys are okay for learning today. You guys are ready for learning today. Bring your pen paper, just because we are going to solve some questions today. We means you guys will solve the questions first today, and then I will explain the answer later, and then you will have to match if you got the correct answer or not. So till yesterday we have seen SJF. SJF was having problem. We could not have the preemption. We are going to solve that by a new algorithm, shortest remaining time first. Criteria is same to same as SJF, shortest job first only, but type of algorithm this time is preemptive. That's the only difference. So it is nothing but I am writing SRTF is kind of preemptive SJF. It is SJF type algorithm only. We will run the algorithm with minimum burst time, but we will run the process with minimum burst time, but preemptive. Later on, if a smaller process comes, then the big process will have to stop. Okay. So scheduling criteria is smaller burst time process first. Process which is having the smaller burst time should be scheduled first. But sir, if two processes are having equal burst time, then whichever process arrives first should be scheduled first. So what is the tiebreaker? Tiebreaker here is FCFS. Now again, I'm telling you guys, FCFS means you'll have to first check the arrival time. If two processes are having arrival time different, whichever process arrives first having smaller arrival time should be scheduled first. Now, if scheduling in that FCFS arrival time is also equal, then you go for the ID later. But please mark my words, write down in your comment box, in your notes also, that first burst time, if burst time equal, then arrival time, that is also equal, then process ID. Okay, type of algorithm is preemptive. Okay, so let me solve a question for you guys, and with that question I will compare exactly how this shortest remaining time first is different than SJF. So this is my question for the first discussion. Okay, SRTF topic, but I will solve this particular process scenario with SJF, shortest job first. Okay, SJF says what? It's a non-preemptive algorithm. Everybody knows it. Non-preemptive algorithm. At time 0, you just see what processes arrived. Can you please write down quickly in the comment box at time 0 what all process already arrived? Just because among arrived process only I will schedule one of them. So sir, at time 0 only P1 arrived, remaining all are arriving later. So I'll have to schedule one process which is the available process P1. Is there any other option you have? No. So P1 we will have to schedule first. Now, just because I am talking about SJF, that SJF has the non-preemptive option. So P1 will completely execute till 8 time unit. Look at this. When P1 was executing, only one time it has executed 0 to 1. After that, P2 arrived at 1 time unit which is smaller than 8. But still we did not stop P1. You know why? SJF. Now, same thing if you will compare later on in SRTF, same thing will change. As in SRTF, we will have to stop current process if later on a smaller process comes. So current process, if executed half, stop. That is called as preemption of the process. Okay, let me continue this. Here preemption not there. No problem. So 0 to 8, P1 only executed, which was the largest process, but we had to execute. Now what happens? Among these, all have arrived till 8. This arrived at 1, this arrived at 2, this has arrived at 3, 4 and 5. So all the processes now available. Among them, I'll have to execute next process. Now I can follow the burst time criteria. Which process is smallest? Sir, two processes are there which are smallest. These and this. P3 and P5. Now, what is the tiebreaker? In SJF also tiebreaker is FCFS. First arrival time. Among these two, which arrives first? Sir, P3 arrives first. So we'll have to schedule P3. Let's run P3 for 1 time unit. 9. Done. P3 done. Now, this is done. This is done. Among remaining processes 1, 2, 3, 4, again select with the smallest burst time. Smallest burst time P5. 1 time unit up to 10. Done. Next smallest process is P4. 2 time unit up to 12. Next smallest process P6 till 16, 4 time unit, and last one P2 5 time unit 21. That's how you will run. Okay, remaining things you can easily calculate. I am not bothered about it just because till yesterday we have solved 3, 4, 5 questions. Same to same procedure we have done. Completion time P1 completion time 8, P2 completion time 21, P3 completion time 9, P4 completion time 12, P5 completes at 10, P6 completes at 16. Turnaround time, completion time minus arrival time. 20, 9 minus 2, 7, 12 minus 3, 9, 10 minus 4, 6, 16 minus 5 is 11. Waiting time, turnaround time minus burst time, 8 minus 8, 0, 15, 7 minus 1, 6, 9 minus 2, 7, 6 minus 1, 5, 11 minus 4, 7. Okay, these are the things which are common in all algorithms. No difference at all. No difference. Okay. Now, average waiting time I want to calculate. 0 plus 15 plus 6 plus 7 plus 5 plus 7 divided by 6 processes are there. 6, 6, 6, 6, 6 चौक 24, 39 divided by 6. Can you please confirm once? You guys are okay to calculate at least. Can you please confirm once if calculations are okay? 15 plus 6 plus 7 plus 5 plus 7. Okay, it should be 40 divided by 6. 6.67. Fine. Now, the same process scenario I have brought here. Same. 0 process P1 to P6, 0 to 5 arrival times. Same burst times 851,214, 851,214. Same to same process scenario. Now, this process scenario I will solve with SRTF. I will give you a tip here that you will have to remember and always follow. The tip is, if any preemptive algorithm you run, then write down the burst time of the processes in a list separately once again. P1, P2, P3, P4, P5, P6, 8, 5, 1, 2, 1, 4. Separately like this you write. Why? Just because when you execute a process half and you preempt, that means stop it, and you run other process. Let's say this one, you run P1 for some time, let's say 2 time unit. P1 was requiring total 8. Already you have run it for 2 time units. Remaining is 6. I'll have to edit it. I'll have to update that. If P1 has run already for certain duration of time, then what happens? You will have to update its remaining time. How much is remaining for P1? Why I am writing it here? Just because when you will solve the question, you will write this also by pen paper. If you update this later on for calculating waiting time, you may take the updated burst time, but you'll have to take the original one. That's why I'm writing it separately, so that there will not be any margin of error. 0% of error I want to have. Okay, so I have written separately. Fine. Now, let's draw the Gantt chart. When we draw the Gantt chart, at time 0, what is process available? Okay, so for that, I will maintain a ready queue. That ready queue will have different processes. Among them, I'll have to choose one. So time 0, only one process available, P1, whose remaining time is 8. Okay, perfectly fine. We'll have to schedule P1 only one option. In preemptive algorithm, which is SRTF, again another point to note down, you will have to check if scheduling algorithm will have to continue this process or will have to schedule other process on every arrival. Write it down, pause the video and write it down. On every new process arrival, scheduling algorithm will have to check whether to continue this process or preempt this process. Okay, so P1 will continue till what time? Completely executed? Nah. When the next process arrives, just check out. This will require little smartness. You guys are smart, I know that. So you don't have to worry about it. Just because we decided to crack the GATE exam, anyway we are smart enough. We decided to be an engineer, anyway we are smart enough. So smartness will say what? Just check out when the next process arrives. Sir, at 1 time unit P2 arrives. Okay, so at next process arrival, we will have to have a decision. So next process arrival is at 1. P1 will run only till 0 to 1. 1 time unit when P1 runs, then its burst time remaining is 7. Why? Sir, P1 already has completed 1 time unit of execution. Total 8, now remaining 7. Now at time unit 1, if a new process arrives, what is that? P2. So P1 already we have and P2 also arrives. We'll have to now check out among P1 and P2 which one to execute. You tell me, type down in the comment box which one to execute next. Sir, P1 is available, remaining time 7. P2 is available, remaining time is 5. The question says, the algorithm says shortest remaining time first, which is having shortest remaining time, execute that. Among these two, shortest remaining time is P2, run it. So what we did, we have sent a player number 1 to bat in on the pitch. Why? Just because that was the only fellow available on the ground. We sent him. You go. Then after 1 minute, what has happened? A player has arrived which is better, batter. So what we will do, we will say this fellow, "Oh, you stop, come back, retired." This fellow will go. We have that option now. So we stopped the current process P1, which is called as preemption happened, and P2 is sent. Being a smart now, you can tell me when the next check will happen. When, till what time P2 I should continue? Till the next arrival. Simple, next arrival is at 2. So what I will do, till 2 time unit I'll execute P2. 1 to 2 executed P2 1 time unit means remaining is 4. Now at 2 time unit, we have option P1, P2 and P3 arrives. 3 processes are there. Among these 3 processes, just check which process is having minimum burst time. P3. Sir, we will have to stop P2. Why? P3 arrives with minimum burst time. What to do in that case? Stop this and execute P3. So P2 will be preempted and P3 scheduled will run for 1 time unit 3. Why 1 time unit? Sir, required time is 1 only. Completed. Finish. Gaya. Done. London ho gaya. Now what? When this process completed, anyway at time unit 3, another process is coming P4. Okay. So at time unit 3, we have remaining processes. P1 is there. Okay. P2 is there. And P4 also arrives. P3 completed. Among these 3 processes, we will have to select one. Which one I'll select, sir? Smallest burst time. P1 remaining is 7. P2 remaining 4. P4 remaining 2. Smaller one is P4. Okay, so let's run P4. We will run P4 for 1 time unit till 4. Why, sir? Arey, smartness, re baba. Dimag. You'll have to use your mind, your brain. At time unit 4, another process comes. We'll have to check if continue this or preempt this. So at time unit 4, till time unit 4, 3 to 4, we have run P4, 1 time unit remaining is 1. Okay, now at time unit 4, P1 is already there, P2 is already there, P4 is already there, and P5 also arrives. 4 processes are there. P1 7 time unit, P2 4 time unit, P4 1 time unit, P5 1 time unit. Remaining time, I'll have to compare remaining time. These, not original burst time, okay? Shortest remaining time first. So which particular process will have to execute? 7411. Sir, tie. Not this particular tie. Nah. That tie, TIE, tiebreaker, yes, will have a tie over here. So what happens in that case? If P4 and P5 both are having same equal remaining time, the breaker is what? FCFS. Which process arrives first should be scheduled next. Which process arrives first? Among P4 and P5? Sir, P4 already arrived first. So we will continue P4 in that case. So we will continue P4 for 1 more time unit till 5 and P4 completed. Done. Now P4 completed also and another process arrives also. Oh, so P1 is still pending. P2 is still pending. P3, P4 gone. P5 pending and P6 arrives. Now among these 4, 1, 2, 3, 4 processes, which one is next? Sir, P5 is the smallest. Execute that. P5 will take 1 time unit up to 6. Completed. Now, again, Next point to note down in your notes. This is another smartness point, a tip to solve the question. In SRTF, such kind of checking is done for arrival. That for the next arrival, if preemption happens or not. When at one time unit P2 arrived with a smaller burst time, P1 preempted, P2 continued. Right? At two time unit, when P3 arrived, P3 continued just because it was a smaller. P2 preempted. Next, at three time unit, P4 arrived, executed. At four time unit, P5 arrived, but still P4 continued just because it was a smaller or arrival time smaller. Now, if all processes arrived already, then there will not be any chance of preemption further. No preemption needed. Why? See, preemption only needed when later arriving process is having burst time smaller than the current running process's remaining time. When no later arriving process, no preemption. So, once all processes arrived, we don't have to bother about it. Just run one by one processes like you run in SJF. So, P5 we completed, yes. Now three processes are there. P1 is having runtime 7, P2 remaining time 4, P6 remaining time 4. Which one I should schedule next? Which process I will have to schedule next? You tell me. Sir, I'll schedule the process with minimum burst time 4. But minimum burst time P4 or P2 also having, P6 also having. Then tiebreaker. What is the tiebreaker? FCFS P2 P6. P2 arrives at 1, P6 arrived at 5, P2 should be scheduled. So we'll schedule P2 4 time unit up to 10 and P2 done. Next remaining P6 is smaller, 4 time unit 14 and then P1 7 time unit 21. Look at this, till 21 all processes were completed, here also completed. Now let's compare the other things, average waiting time from previous and this one. Let's complete this. P1 completes. Okay. Now, another thing is in preemptive algorithms. This is another problem students face. It's not problem, it's the mistake they do. P1 completes where? See, P1 executed here till one time, but at one time P1 did not completely executed. Now, later on P1 gets the chance here and it has completed at 21. So P1 completion time is 21, not 1. Please take care of that. At the end, when P1 completed, after that never executed, done at 21. P2 here also executed, but when completed at 10, it has completed. P3 at 3, P4 at 5, P5 at 6, and P6 at 14. Turnaround time, completion time minus arrival time, 21. 10 minus 1, 9, 9 minus 3, or 3 minus 2, 1, 5 minus 3, 2, 6 minus 4, 2, 14 minus 5 is 9. Waiting time 21 minus 8, 13, 9 minus 4, 5, 4, 0, 0, 1 and 5. Okay, you calculate now average waiting time, how much it is. Average waiting time will be 13 plus 4 plus 0 plus 0 plus 1 plus 5 divided by 6. 5 plus 1, 6, 6 plus 4, 10, 23 by 6. $3.83. Now you just see same process scenario, but average waiting time here to here is almost half. Not exactly half, but yes, almost half. How? This is also favoring the shortest jobs. This also favoring shorter jobs. But just because of preemption, this SRTF even reducing the average waiting time. Look at this. Now, in the preemptive algorithms, What else can be asked? Additional questions can be asked is this: how many times process switch happened? How many times process switch happened or context switch happened? Look at this. From P1 to P2, one process switch. P2 to P3, another. 3 to 4, another. 4 to 5, another. 5 to 2, 2 to 6, 6 to 1. How many context switch happened? 1, 2, 3, 4, 5, 6, 7. 7 context switch occurred over here. So another type of question which can be asked is number of context switches. How many context switches happened here? 7. Excluding at first and last place. Here we are not counting before P1, we are not counting. After this 21, we are not counting. So total 7 context switches occur. This is another question. So in preemptive algorithms, that can be another question. What is that? How many times process switch or context switch happened? Just check out the Gantt chart. You can see over here from P1 to P2, 1, 2, 3, 4, 5, 6, and 7 times switch happened from one process to another. That is the context switch or process switch. Okay. So this is another question. Look at this. In SRTF, it is 7, but in SJF, it is not 7. In SJF, it is very easy. If you have 6 processes, then 5 context switch will occur. Any non-preemptive algorithm, context switch will be number of processes minus 1. Look at this. 1, 2, 3, 4, and 5 times switch happened. 6 processes, 5 context switch. In the non-preemptive. Preemptive, you will have to draw the Gantt chart and you will have to calculate it. There is no any other option. Okay, let's solve this question then. It is now your chance to show your skills. I will give you 2 minutes to solve and get your Gantt chart. Exactly 2 minutes. Try. I will give you 2 minutes. Just get the Gantt chart. That's important. Get the Gantt chart. If Gantt chart is over, then that is enough. Make the Gantt chart. That is important. As I asked you, 1 more minute I'll give you. If you want more time, you can ask in the comment box or need more time. I will give you no issues. Maintain ready queue if you cannot solve the question directly, so that you will always be correct. That's the most important part of solving the questions. Correctness. Okay, let's solve the question. If you are in the middle, you can join me and just see if I am solving the question correctly and you are in the correct path or not. At time zero, what process is available is only one P6. P6 only arrives. Look at this. This time, for your attention, I have given the sequence of arrival time different so that you guys will always concentrate correctly. At time zero only P6 arrives. So I'll start running P6. I will run P6 till one time unit just because at one time unit another process arrives. New process arrival means I'll have to check. So P6 runs for one time unit, remaining is 3. Fine. Now at one time unit, another process arrives. P6 is already there and at 1 P4 arrives. Okay. P4 is smaller than P6. P6 remaining time 3. P4 is 2. So we'll have to preempt P6. P4 should be scheduled. P4 will run for one other one time unit. The remaining is 1. Now at 2 time unit, another process arrives. Which one is P5? Now P5 remaining time 1, P4 remaining time 1, P6 remaining time 3. Among these three, smaller is 1. But two processes are having a smaller. So I'll go with the arrival time. Arrival time of P4 is smaller. We'll go with P4. P4 we will continue till 3 completed. Okay, at 3 time unit, we already have P6 remaining, P5 remaining, and at 3 time unit, P3 also arrives. P3 arrives. Now, this one, and this one. Among these three, smallest process is either P3 or P5. Now, among P3 and P5, which one is smaller? Both are equal. Which one do you execute? Whichever is having smaller arrival time. If bus times are equal, check out the arrival time. Arrival time P5 is having first. Yes, it arrives first at 2. So P5 will be scheduled next. P5 scheduled for one time unit till 4 and P5 completed. Now at time unit 4, we have P6 remaining, P3 remaining, and time unit 4, P1 arrives. 1, 3, 6. 1, 3, and 6. Among these three, of course, P3 is the smallest. So P3 we will run for one time unit up to 5 completed. Now at time unit 5, P2 also arrives. So P6 remaining, then P1 remaining, and P2 remaining. Among P1, P2 and P6, P1, P2 and P6 with 3 time unit. Which one is the smallest? Of course P6. So we will run P6. Now no any new arriving process we have. So we'll continue P6 for 3 time unit up to 8. Then next at time unit 8, we have P1 and P2 remaining. Among P1 and P2, we will run P2 first, the smallest one, for 5 time unit up to 13, and then at the end P1 for 7 time unit 20, and all processes done. 12, 13, 14, 15, 16 plus 4, 20. Look at this till 20 unit. All processes are done. Just check out if anything you could not understand here. Just confirm once quickly so that I can understand your problem and I can explain. If you understood, okay, let's go and calculate the rest of the things. When P1 completed at 20, completion time of P2 13, P3 5, P4 completes at 3, P5 completes at 4, and P6 completes at 8. Turnaround time, completion time minus arrival time. 13 minus 5, 2, 2, 4 minus 2, 2, 8 minus 0, 8. Waiting time, turnaround time minus burst time 9, 3, 1, 0, 1. 8 minus 4 is 4. Okay, let's calculate average waiting time. which is 9 plus 3, 12 plus 1, 13 plus 0, 14 plus 1, 15 plus 4, 19 divided by 6. 2.86 approx. Is it it? 9 plus 3 plus 1 plus 1 plus 4. 18. Oh, it is exactly 18 divided by 6, 3. Average waiting time is 3. Okay, how many context switch occurred? Just tell me how many context switch occurred. 1, 2, 3, 4, 5 and 6. 6 context switch occurred. 6 times process switch happened. Okay, fine. Another question. We have another question for your practice. As I told you guys, we will practice this just because it is needed. SRTF practice is needed. So another question for you. Solve it. I'll give you 3 minutes. 3 minutes. I'll give you 3 minutes to solve this question. See, every question has little different challenge. Last time I have given sequence of arrival time different so that your concentration should be better in that case. It was not like P1 after P1 P2 arrives and after P2 P3 arrives. This time another challenge you are having in this question. Just see if you can understand that. Okay, let me solve for you guys and just check out if you guys are correct or not, if you did the correct thing or not. So I am having a ready queue here. And I'll write down the time here. At time 0, only one process P1 is arrival. Only P1 arrived, so no option at time 0. We'll have to start with P1. I'll run it for 1 time unit. Remaining is 8. Why I'll do that? Just because at 1 time unit another process P2 arrives. So when P2 arrives at 1 time unit, we have two options now, P1 and P2. P1 remaining time 8, P2 remaining time 6. Of course 6 is smaller. P1 will be preempted, P2 runs. P2 runs till 2 time unit, remaining is 5, and at 2 time unit P3 arrives. Oops. P3 arrives, 2 time unit, P1 is there, P2 is there, and P3 arrives. Now look at this. At time unit 2, if P3 arrives, P3 is having smaller burst time. P1, P2, P3, these three processes are there. P3 is having smallest burst time, 4. So we'll have to preempt P2 and run P3. P3 runs for 1 time unit. Remaining is 3. And at time unit 3, another process P4 arrives. So P1, P2, P3, P4 remaining. Now among these 4 processes, P4 is the smallest, P3 preempted, P4 runs. 1 time unit 4, but at 4 no any new process arrives. P5 is arriving at 6. So at 4 no process arriving, no. Why to stop? Till 5 you execute P4 and complete it. Till 5 we completed P4 just because we'll have to check the next arrival. Next arrival is at P5 is arriving at 6. So till 6 we don't have to worry about preemption. So P4 completed till 5. Now at 5 time unit, what are the remaining processes? P1, okay, P2, okay, and P3. These 3 processes are remaining. Sir, P5 not yet arrived. If at 5 time unit P5 not arrived, we can't schedule it. Okay, now what I'll have to do? I'll have to schedule one among them. Smallest one among them is P3. We will continue P3 for 1 time unit till 6, remaining time 2. And now at time 6, P5 arrives. Now at time 6, P5 arrives. What happens? P5, at time 6, we have smaller process. Which one? P1, P2, P3 and P5 remaining. Sir, P5 is the smallest. So we'll have to preempt again P3 and P5 will continue till 7 time unit. Now no any new process arriving? No. Then we can continue remaining processes easily one by one. Okay. So next process P3 for 2 time unit up to 9. Then P2 remaining time 5 only till 14 and 8 time unit P1 runs till 22. Let me just reconfirm. 10 plus 2, 12, 13 plus 9, 22. Yes, 22. Okay, rest of the things I'm leaving at you guys. Calculate the completion time, turnaround time, waiting time from here. P1's completion time is 22, P2's completion time 14, P3 is 9, P4's 5, P5 7. And turnaround time, waiting time you can calculate by the formula regular method and just calculate the average waiting time. Once you calculate, drop in the comment box your answer that average waiting time you are getting is this. Then remaining all other members also will comment their answer or will confirm that they also got the same answer so that you guys can match up with your answers. Now, the topper mindset person will solve this question till the end. Average person will try, okay, let me try if I can get the answer correctly and match with the other answers or not. And the person who don't want to qualify or just preparing for normal preparation, not aiming for higher rank, will say what? We have already solved 4 questions. Why to solve this? I know how to do that. I can do it in an exam. I did all 4 questions. You did not. I practiced and I have solved the questions. You did not. Yes, it is truth. It is fact. You'll have to practice. When you will practice the question from scratch, I have solved the question in 3 minutes. You will solve the question in 5 minutes. On an average, you will get answers or you will get per question less than 3 minutes. Such kind of known question also, if taking more than 3 minutes, means it's a waste of time for you for the preparation. You'll have to practice such kind of question that much that you can solve such kind of question in less than 3 minutes. That's more important. That's why practice is needed, boss. Practice is needed. Okay, fine. How many context switch can you please type down? Context switch in the last question. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, and 8. 8 times context switch occurred. Okay, fine. Okay, some points here. The SRTF algorithms give minimum average waiting time and minimum average turnaround time among all algorithms. Whichever you name the algorithm, whichever among all possible preemptive, non-preemptive, all SRTF gives you the minimum average waiting time and minimum average turnaround time. See, SJF gives you minimum average waiting time and turnaround time among only non-preemptive algorithms. If you keep only non-preemptive, SJF gives you minimum average waiting time. If you keep only preemptive, SRTF. If you keep all preemptive, non-preemptive, everything, then to SRTF. SRTF gives you minimum average waiting time among all algorithms. Throughput is also good just because in continuous run you are running the smaller process first. So number of processes executed will increase. Disadvantages: in practical implementation, we don't know the burst time of a process, hence it is not practically implemented. And longer processes may suffer from starvation just because this process is actually, or this algorithm is actually favoring the smaller processes. So we can have this starvation. Why it is leaded? Just because it is not a fair algorithm. This algorithm is not giving fair chance to each and every process. It is favoring, or it is biased towards the smallest processes, and it is against towards the bigger processes. It will not run bigger processes until it completely execute all the smaller processes. So for SJF and SRTF both, you can write down in your notes starvation. Why starvation occurs? Just because it is not the fair algorithm. Okay. Now, tomorrow we will discuss about the priority based algorithms. In the priority based algorithms, you know what happens? We have the criteria priority of each process. So apart from the given three things, process ID, arrival time, and burst time, you will be having another column of priority every time in the priority based algorithm. So priority based on priority, you will have to schedule the process which is having the highest priority first. Priority based algorithms are both types, preemptive also, non-preemptive also. You can select one based on given in the question. Question says you solve with the preemptive version, you solve it through that. If question says non-preemptive, you will solve with that. We'll see tomorrow, we will solve the questions, and then after that we will move ahead to one of another important scheduling algorithm, which is round robin. So in gate questions, you will be finding questions of FCFS, SJF, SRTF, priority based, and round robin. These 5 types of questions are mostly asked, and one more type of questions are asked which are involving the IO operations. 2, 3, 4 questions we will solve from there also, and you can understand how we will solve those type of questions. Okay, so for today we are done. So tomorrow we will be discussing the priority based algorithms. Next day we will be discussing round robin. Next day we will be discussing the priority multi-level queue and multi-level feedback queue scheduling, and one more we will be having a session for practice. More questions we will be discussing, different kind which are asked in the examination from gate perspective. Okay, so 5 sessions more we will be having to complete this CPU scheduling. Okay, fine. Thank you so much for joining and listening out. If any doubt, query, question you guys are having, please drop comment in the comment box so that we can understand and solve those queries. Thank you so much. Have a great day. Happy learning. Bye-bye.